Now, we're trying to get away from doing a lot of the toxic organic reactions, and nylon's one of them. So you can see that both products there are quite toxic. And so ideally, we can do this once at a demo, and hopefully you can get a better picture because you can see it clearly with the video anyway. And so what we're doing is adipole chloride and hexamethylene diamine. Now, it can actually have instead of that chloride group, you can have an OH group. So instead of having HCl come off, which is quite toxic, you can also have water come off and other small molecules as condensation. And you can see here that I just put a bit of red food colouring in. So one's more dense than the other. And I should have a careful look, but you should be able to analyse which one you would think would be more dense. And the carbon chains on both are 6,6, so this one's called nylon 6,6. And accidentally spelt a little tiny bit of that. And so what happens is one's more dense than the other, so it layers on top. So the reaction is actually in between the two layers. And so what you can get is you pull it out and you just keep rolling it on. I eventually give up before I end up using it all because it just goes on and on forever. And so what's so special about nylon 6,6? Well, that carbonyl group, the COO is negative, and the NH, the amine group, is positive, and so they link up with hydrogen bonds between them. Now that makes nylon very, very strong. If you want to see something even stronger, you just look for something like Kevlar. So if I just jump to Kevlar, you can see that there's even more of these hydrogen bonds going on, and so Kevlar's even stronger still. Okay. Now there's two other ones that we want to talk about. The other one I want to talk about is slime. So this is polyvinyl alcohol. This was really, really popular a few years ago, and with kids playing with it all over the place. And I just never felt comfortable with kids just handling it, playing with it. They're never eating it even. And with all the problems with infertility that we have, borate causes infertility. I was really uncomfortable with the fact how popular slime became. Now this one's sort of special that the borate sort of catalyzes the polyvinyl alcohol. So there's all these OH groups, and it doesn't fit as nicely as nylon, so it's not strong. And so this is actually a non-Newtonian fluid, and the hydrogen bonds can break and form easily. So the slime itself you can break apart and then put it back together. And so these chains link in. If you hit it has more resistance, just like cornstarch, where the strands react when you smash them, but then they just form into a goop when they can slide past each other. And so that's to do with these sort of random, less linked in structural hydrogen bonds that allows it to open and break quite easily. And the last one is you're thinking, what's the use of this? One's just polyacrylate is really good at forming hydrogen bonds with water. Now, I couldn't actually find anything to get this structure, so I had to draw it in myself. You can see it perfectly matches water, drawn in with the red. And this stuff is just magic at absorbing water. So that's good for diapers, and there's lots of other applications, but that one seems the most obvious. This is the only one that's not toxic. And so what you can see is just put a bit of water and swirl it around, and there's no letting go of that water. It just holds onto it and just stays there, stays in the beaker, just won't escape from it. And you can see from its structure, it's just completely layered with the perfect attraction to water to lock it in place, unlike the other structures.